Alright, so we're gonna go over the review. Thank you for everyone that reached out. This is Jamie's pictures. Thank you. These are some of the clearest ones. Just make sure you attempt the question first, and then we'll go over it. On the side, I'll have here the notes for so you have the questions on the left. If I have to write anything or draw anything, I'll write here on the right because I can't write with the mouse. But yeah, so we'll start on the first one. In order to use binary search, so remember binary search, we went over it. It's the one where you have, so binary search is the one where you have a list of numbers. So 1, 2, 3, 4, 5, 6, and 7. There's your list. And let's pretend that we're looking for number 3. So the target is number 3. So in binary search, you would first find the middle, which is 4, right? And you check, is 4 my target number? And it's not. And then you would check, is my target number less than or equal to 4? Or greater than or equal to 4? And then the target is 3, right? So then 3 is less than 4. So then you would delete this whole thing. And then your new list is this right here. And then you check the middle here, it's 2. So then you check, is 2 less than or greater than 3? It's less than, so then you would delete this part, and you're left with 3. So it's the search where you have to have everything, or you have to delete half of the list at every step. So it says, in order to use binary search, the data must be linear. We don't know what linear data means. Unsorted, that means that there's no order. So remember our list, it's 1, 2, 3, 4, 5, 6, 7. It does have order, so it's not unsorted. Sorted, that means it has order. So like our list here has order. That's a question mark and a check mark because this one looks right. Binary, we don't have any binary here. It's just the name. So that's not it. And then random, these are not random data, right? They're like ordered numbers. So it's not random. The answer is sorted. So remember, binary search only works for sorted lists. The following array contains a row bar represented as a triangle, which is initially facing right. So it's right here pointing to the right. Which of following code segment is intended to move the robot to the gray square, so it wants to move here. We have a missing statement. So let's see what this code does. So it says repeat 4 times. So we're going to move forward. So it's going to move here. That's that one. And then it says rotate right. So it's going to be pointing. This is the left. This is the right. So it's going to now point this way. And then it repeats. So we're going to do that 4 times. So then it's going to move forward again. Now it goes here. And then it rotates to the right. This is the left. This is the right. Because it's pointing down, right? So then it's going to go point this way, then it repeats again. Move forward, so it moves here, and then rotate right. This is the left, this is the right. Oh, I can't, right. That's an R. So it's gonna point up now, right? And then that's, so this was 1, this was 2, this was 3, so we have to do it again because it says 4 times. So then you move forward 1, so now it's gonna be here. It's gonna be here, and then it rotates right. So it's gonna point this way. So it's just like it started. It goes back to its starting position, but then you have a rotate left, so then it's gonna rotate up, so now it's pointing up. How can I do this? Yeah, so now it's pointing up, and then it says move forward, so it's gonna move here, and then it says rotate right, so to the right. So this whole thing, it made the robot go 1, 2, 3. I'll erase this. It's because this eraser, for some reason, doesn't work. So we have to look at it. I don't know what to do. I'm not gonna erase it. Oh, bro, I didn't erase it. Okay. So all this code, this whole block of code, what it did was it made it move this way, then this way, then this way, then up this way, and then it stayed pointing this way, like that. So all it did was move it up 1, right? So then how many times do you want to move up to reach the gray square? So it would be 1, 2. So yeah, that's literally the missing statement. You want to move, so this happened if you repeat it 1 time. If you were to repeat it again, the path it would take would go 1, 2, 3, 4, 5, and then point this way. Because it does whatever is the blue. Again, so this would, the answer for this one would be repeat 2 times. Which are following lists? Which are following lists of algorithmic efficiencies? So algorithmic efficiencies are ordered from least efficient to most efficient. So for time efficiency, remember that you have this graph with the size and the time. And so there were different kinds of efficiencies. So you have this one, which is linear. You have the one that's less than linear, which is sublinear. You have the one that goes like this, and that's exponential. No, that's not exponential. That's polynomial. And then you have the one that goes like this. This one is exponential. So then you look at the time axis right here. So which one has the lowest amount of time? And you could argue that it's a polynomial, but in the long run, polynomial increases its time. The one that keeps it low, right here, the lowest point in time, would be sublinear, right? So sublinear, since it's the fastest, it's the most efficient. So from least to most efficient, sublinear is right here. So then the next one that takes the least amount of time would be linear, right? That's the second one. So then it's linear. The next one is poly, and for a smaller size, notice how exponential takes a really long time, while polynomial takes a very short amount of time for a small size. So then the next one is polynomial, and then the least is exponential. So whenever you think of time efficiency, remember this graph. And we drew it out before I left. You have it in the paper, so make sure you go on the box and look at the paper. If not, it's right here. This is what you should remember when you see time efficiency. And then the order. So linear, polynomial, exponential. In this case, they want least efficient, so then the least efficient is exponential. So exponential. And that's the only one, literally. Constant. Constant means it takes the same amount of time regardless. So constant would look something like this. Oh, I don't like why. Something like this. So it's just constant. It stays the same throughout, regardless of the size. So constant would be right here. Constant. It's the most efficient. So the order would be this one: exponential, then polynomial, then linear, then you have sublinear, and then constant. So it's D. So number 4. It says, let me zoom in a little bit. Data Helper is a mobile application people use to select a restaurant for a group meal. Each user creates a profile with a unique username. So you have a unique username and a list of food allergies or restrictions. Each user can then build a contact list of other users in the app. A user who is organizing a meal with a group selects all the members of the group from the user's contact list. So you select all members of the group from a user's contact list. The contact list seems important. The application then recommends one or more nearby restaurants based on whether the restaurant can accommodate all the group members allergies and restrictions. Suppose that Alejandra is using Dina Helper to organize a meal with Brandon and Cynthia. So you have Alejandra, you have Brandon, and you have Cynthia. Which of following data is needed for Dina Helper to recommend a restaurant for the group? Okay, so that's a long question. So we want to know the data needed to recommend a restaurant. And it says right here, where's my highlighter? Is this a highlighter? Yeah. So the application then recommends nearby restaurants. It's not gonna work. So we want nearby restaurants. So that would be like your location. Based on what the restaurant can accommodate all of the group members. So you want everyone's allergies and dietary restrictions from everyone, all of the group members. So you have location, you have restrictions, and that's it. It says which of following data are needed to help find a group. Each of the group members list of food allergies or dietary restrictions. So yeah, we need this one, right? It's right here. We need a list of everyone's. We need location, so yes. So we need an answer that has 1 and 2. So then this one's wrong, this one's wrong. So now we need to see if we have to include 3 or not. So the usernames of the people on Brandon's and Cynthia's contact list. So Alejandra is the one making the group. So you don't need to know who Brandon and Cynthia have as contacts, right? That's irrelevant. Doesn't matter. So if it has 3, it's not the answer. That's not your answer. Your answer is A. You just need the allergies and restrictions and the location. Pretty self-explanatory. 5. Which of following data is not provided by Alejandra but is necessary for Dina Helper to recommend a restaurant from the group? Okay, so Alejandra, she only provides information from her profile, and it says right here, Dina Helper is a mobile application. Each user creates a profile with a unique username. So she provides a username and her allergies and restrictions. That's what Alejandra provides. She also provides a contact list. So that's information that Alejandra provides. So which information does she not provide that is needed right here? So you could think of which information here does Alejandra not provide. She provides her location from her phone. She does not provide the dietary restrictions, right? So let's look at these. So Brandon's contact list. Is Brandon's contact list necessary for recommending a restaurant? Like we said right here, their contact lists are irrelevant. So this one's no. So any answer with 1 is not the answer. Let me change it back to blue. So no. Information about which restaurants Brandon and Cynthia have visited in the past. again, this is irrelevant. And then information about which food allergies and dietary restrictions can be accommodated at different restaurants near Alejandra. It's this one. It's 3. Because Alejandra does not provide information about restaurants. She only provides her allergies, right? That's the only thing that we provide. The username and the allergies. We do not provide any restaurant information. But it's necessary for the app to recommend the restaurant because the app knows, or the app needs to know if that restaurant can accommodate for her allergies. That's why it's B. So 5. A computer is performing binary search on the list of numbers below. How many iterations are required to successfully locate the index of number 21? So we're looking for number 21. So again, for binary search, we have 3 steps. The first one is to find the middle. The second one is to compare. And then the third one is to eliminate half of the list. And then you repeat for binary search. Those are the steps for binary search. So let's write down our list. We have 1, 2, 3, 5, 8, 13, and 21. So first, let's find the middle. And it's very obvious that it's 5. So this is our middle. The target, remember, it's 21. So is 5 greater than or less than 21? 5 is less than. So then we delete this half. And this is our new list. And the new middle is 13. So it's 13. Oh, this was the first guess. Or the first repetition, the first iteration. Then we check 13. Is 13 less than or equal to 21? It's less than, right? So this is our second. Get rid of this part, and then the last number is 21. So is 21 our number? That's a yes. So this is the third one. It took us 3 tries. That's the answer right there. So again, you don't need to know the exact definition, but you need to know how to perform binary search. Because these questions are going to be on your exam. Alright, page 7. A computer is performing a binary search on a sorted list of 256 numbers. What is the maximum number of iterations needed to find a particular number in the list? So the keyword here is maximum. So let's pretend you have one. I won't write it here. I'll write it on this side. So let's pretend you have 1, 2, 3, and you have every number up until 256. So you're gonna have a very big list right here. And so the question is, how many times can you, how many times are you gonna have to guess at most? So let's pretend that your number is 256. So it's the very edge. All this means is how many times can you have 256. So let's try. So let's divide 256 divided by 2. That's 128. That's one time. So 128 divided by 2. That's 64. That's 2. Then 64 divided by 2. That's 32. That's 3 times. 32 divided by 2. That's 16. That's 4 times. Then 16 divided by 2. That's 8. 8 divided by 2. That's 4. 4 divided by 2. That's 2. And then 2 divided by 1. That's 2. And you have 4, 5, 6, 7, and 8. Until you can't divide it anymore, right? It's just gonna stay at 2. Oh, 2 divided by 2 is 1. One of you probably caught that. So that's as low as you can get. We did it 8 times. And you have to divide by 2 because remember that you eliminate half after every repetition. So if you're eliminating half, you're dividing by 2. So in this list of 256 things, the first time you eliminate half, you will be left with 128 things. And then after 128 numbers, you're going to be left with 64 numbers. And then 32, and then 16, all the way until you're only left with 256, which is the last repetition, because you found the number. So it would be 8. And which of the following problems is a heuristic solution appropriate? So heuristic, remember that it's not a solution, but it's more but a good enough approximation. So it's an approximation. It's not a solution. So find the combination to a lock. You could find a combination to a lock pretty easily, right? Just try it. Find the best combination of ingredients for spaghetti sauce. Find the biggest item in the list. That's not it. Find the biggest item. It's not heuristic. Playing chess. No, chess is solved already. Combination. So having an n amount of numbers, that places a limit in how many combinations there can be. The best combination of ingredients, though, how many ingredients are there for spaghetti sauce? There's a lot. A lot. So you can never really give us like this is the best, because there might be some ingredients that you haven't tried. It's not a solution, but it would be a good approximation of like, oh, this tastes really good. Having the n here means there will be a limit on how many combinations there can be. So this wouldn't be the answer. It would be the spaghetti. memorize this formula. So you have sequential time. Sequential is one computer. So it does one thing, another thing, another thing in order like this. And then you have parallel. So parallel means you have multiple computers. So you have a computer doing this, but at the same time you have another computer doing this other thing. So you two computers running at the same time, while sequential takes only one. Uses only one computer. As it says, a social media company previously used a sequential algorithm to process data when users upload photos to their photo gallery. The sequential algorithm took 28 milliseconds. A software engineering company decided to improve the algorithm by redesigning and using parallel. The redesigned algorithm now takes 7. So calculate the speed up. So again, speed up is sequential divided by parallel. So if you have speed up, we know that the sequential was 28 and the parallel was 7. 28 over 7 is 4. So that's your speed up time. And then it says, an AI company designed a sequential algorithm to generate 500 words of text when the user types in a prompt. The algorithm takes 1 second to read the prompt and then takes 59 seconds to generate the text and display into the screen. After the company grew in size, they hired 3 additional software developers to redesign their algorithm in parallel. The new algorithm will take 1 second to read the user prompt, but it only takes 0.05 seconds to generate and display the text. So notice how this is the same to read the user prompt. It's still 0.01 on both, so then this is not it. We don't care about this. So we care about these other numbers. So 59 speed up 0.59 divided by 0.05. And I'm gonna solve this, but this would be your answer. You could like just do 59 divided by 0.05. That can be your answer. It would be like 0.12 or something. I mean 12, barely. I think it's like 12, something like that. 11.9. But that can be your answer. That would be an acceptable answer. Next you have, which of following best explains how algorithms that run on a computer can be used to solve problems. So all problems can be solved with an algorithm that runs in a reasonable amount of time. So that's false. There are problems that cannot be solved, right? All problems can be solved with an algorithm, but some algorithms might need a heuristic to run in a reasonable amount of time. So yes, some might need a heuristic, but that's not solving, right? So all problems cannot be solved. All problems can be solved by an algorithm. Again, that's wrong. But some algorithms might run in an unreasonable amount of time. There's some problems that cannot be solved by an algorithm. This one's correct. There are unsolvable problems. The following grid contains a robot represented as a triangle, which is initially facing forward to the top of the grid. The robot can move into a white or gray square, but cannot move into a black region. So we wanted to do that. Which of following code segments can be used to move the robot to a gray square? So repeat 3 times, move forward. This repeat 8 times, that's wrong. Alrighty. If you repeat 8 times moving forward, it's going to go into a black square. So repeat 3 times, move forward. 1, 2, 3. And then repeat 2 times, move forward again. Okay, this one's wrong as well. Repeat 2 times, move forward. 1, 2. Rotate left, so then it's going to look this way. And then it says something this one. Repeat 3 times, move forward. That's also wrong. So this one, move forward 3 times, so 1, 2, 3. Then rotate left, so then it's going to look down. Then it says move forward 2 times, so 1, 2. It's right here. Rotate right, so then it points this way. And then repeat 3 times, move forward, so 1, 2, 3. Yeah, so it's that one. It goes like this. It's this one. You have for which of the following problems is using a simulation. Why is it black? A simulation least likely to be beneficial. So remember, simulations, they're cheaper, less risky for like large experiments. Determining the longest word in the textbook. This is not that beneficial. Minimizing the customer waiting times at a bank. Predicting the outcomes of weather patterns. So for weather patterns we use simulations, but we want the ones that doesn't do, so this one is not it. So in the information of a galaxy, we cannot go into space and check it, right? So simulation is the best that we can do. So then this would also be very beneficial. I think this would be more beneficial than this, right? We don't really care about the longest word in the textbook. So then that would be the answer, because we want the least beneficial. A team of programmers are designing software. One portion of the project presents a problem for which there is not an obvious solution. So we don't have an obvious solution. After some research, the team determines that the problem is undecidable. So there is no yes or no answer. Which of the following best explains the consequence of a problem being undecidable? The problem can be solved algorithmically. There's no possible, but it will require an amount of time. No. So if it's undecidable, then that means it cannot be solved. So these two are wrong, because they cannot be solved. There is no possible algorithm that can be used to solve all instances of a problem. There are several different possible algorithms, so no. So there is no possible algorithm that can solve all instances of a problem. That's what undecidability means. So there might be some instances where the problem is a yes answer, but it cannot answer all of them. That's why it's undecidable, because the problem cannot be decided every time. So let's see. A researcher is analyzing data about students in a school district to determine whether there is a relationship between grade point average and record of absences. The researcher plans on compiling data from several resources to create a record for each student. The researcher has access to a database with the following information about each student. So you have last name, first name, grade level, and GPA. The researcher also has access to another database with the following information about each student. So you have the absences and the late arrivals. Upon comparing the data, the researcher identifies a problem due to the fact that neither data sources uses a unique ID number for each student, which one best describes the problem caused by the lack of unique ID numbers. Okay, so this is again a very long question. You have grade level, you have GPA, you have absences, and you have late arrivals. You also have first and last name. But you don't have a unique number. So then what happens when the person has the same first name and the same last name, and then they have the exact same number of absences and late arrivals, and they're in the same grade level, and they have the same GPA? You cannot identify them. So that's the problem. Students who have the same name may be confused with each other. Yeah. Students who have the same grade point average? No. Students who have the same grade level may be confused with each other? No. Students who have the same number of absences? No. It's if you have the same name, right? Because then, since there are two different databases, how do you know which one is which? Almost done. Okay, so we have delivery trucks enter and leave the depot through a controlled gate. At the depot, each truck is loaded with packages, which will be then delivered to more customers. As each truck enters and leaves the depot, the following information is recorded and uploaded to the database. So you have an ID number, you have weight, you have date and time, and you have entering or leaving. Is the only information in the database which following cannot be answered. So we're looking for one that we cannot answer with this information. So on which day in a particular range of dates did the greatest number of trucks enter and leave? So we know enter and leave, right? Because we know it's right here on the fourth one, right here. We have which day. Yeah, we have date and time. And we can count them. So yeah, we can't answer this one. So this is not the answer. What is the average number of customer deliveries made by each truck on a particular day? So we don't know the customer deliveries. That's a maybe. Because we know the truck, we know the weight, we know the date and time it passes, we know whether it leaves or enters, but we don't know how many deliveries it made. What is the change in weight of a particular truck between when it entered and when it left? So we know the weight, yeah, right here. And then we know when it entered and we know when it left. So yeah, that checks out. So there's not our answer. Which truck has the shortest average time spent at the depot in a particular day? Yeah, so we know when it enters and when it leaves, so we know how much time it spent. And then we have the day, yeah. So this is also not the answer. The answer is B. It says for the question or incomplete statement below, two suggested answers are correct. So we have two answers. Which are following is a benefit of using a simulation instead of an experiment? So simulation, it's cheaper, faster, and less risk. So simulation allows investigation without real world limitation on safety. Yeah, so that's a risk. That's correct. A simulation can be used to model real world events that are impractical for experiments. That one seems right. A simulation always produces the same output. That's false. Simulations can be different. So you know, in the coin flip, if you did it, you would have gotten different numbers compared to the video or to your classmates. A simulation produces results that are more accurate. That's false. They're not more accurate. Yeah, so it's A and B. Nice. We're almost done. So this says a group of students take hundreds of digital photos for a science project about weather patterns. Each photo file contains data representing the level of red, green, and blue for each pixel in the photo. The file also contains metadata that describes, so remember, metadata is information about the data. So it contains date, time, and location. For which of following goals would analyzing the metadata be more appropriate than analyzing the data? So metadata is information about our data. So things about the picture, not the actual picture. So determine the chronological order of photos. So yeah, so we know the date and time. So this would be the metadata. Yes, that's one answer. Determining the number of clouds in a particular photo. The clouds that would be in the actual image, not in the metadata. That's not the answer. Determining whether a photo is suitable for printing in black and white. Okay, so we know that like the levels of the color pixels. I don't know about this one. Let's see, determining whether two photos were taken in the same location. Okay, so location is metadata. So yes, this is another answer. Yeah, so these two are wrong. You would figure this out with the picture. Like, oh, is it able to be printed in black and white or not? Just by looking at it. You don't need to read the metadata. Then a computer scientist is analyzing 4 different algorithms used to sort a list. The table shows the number of steps each algorithm took to sort. So we're looking at the amount of steps. You could think of this as time. So how long did they take? So for a list of 1, this one took 10 seconds, this one took 2 seconds, this one took 1 second, and this one took 1 second. That's how you can look at it. So based on the values of the table, which of the following algorithms appears to run in reasonable time? So which one is the fastest, or the 2 fastest? So look at this one. It increases at the same rate as the size, right? So for 1 is 10, for 2 is 20, for 3 is 30. This is linear. So algorithm A is reasonable. For reasonable time, we're looking at reasonable are linear is reasonable, sublinear is reasonable, poly is reasonable, exponential is not reasonable. So this one, 2, 4, 8, 16, 32. I think this is growing exponentially. 1, 4, 9, 16, 25. This looks like a function. This one also is exponential. So you're looking at the 2 fastest ones. So A and D. Well, not the fastest ones, because this one's not faster than this one. But this one, look at how it grows. It grows faster than this one. Because this one is 4, then 9, then 16, then 25. This one jumps from 16 to 32. That's bad. This one's also really bad. 120. That takes too long. And then the last one, in a certain district, 20% of voters are expected to vote candidate A, so 20%. The computer program below is intended to simulate the result with n voters and display the number of votes received by candidate A. So repeat n times if which if following can be used to replace the missing condition. So you want to count how many votes candidate A had. So that's what this sum should have. This should start counting the number of votes. Candidate A. And you're looking at 20%. So 20% would be 1 out of 5. This is equal to 20%. 20. That's this one, right? A. That's one of them. This is not 1 out of 5. This is 1 out of 10. But then less than or equal to 2, then you would have 1 and 2. This whole thing is 2. And then if you divide this out of 10, you have 1 over 5, which is what you want. It's this one. Yeah. Hopefully you got them right. Let me know if you have any questions. Bye.